So these are the exercises for section 4.2, one sample means of the t-distribution. So the manufacturer of a dietary supplement claims that its product will help people lose weight. The company obtains a random sample of 50 adult males aged 20 to 74 who take the supplement and finds their mean weight loss after 8 weeks to be 0.9 pounds, with a standard deviation of weight loss of 1.2 pounds. Test the hypothesis that dietary supplement actually results in weight loss, which would be also said as the mean weight loss is more than 0 pounds, using a 0.05 level of significance. Our first step is to write our hypotheses. So the parameter of interest here is mean, so we're looking at mu. And what we are believing is the status quo is that the standard that we believe is that there will be no weight loss. So the mean weight loss, if there's no weight loss, would be 0 pounds. However, if we do think that this claim that we want to test is that it results in weight loss, that means that the mean weight loss is more than 0 pounds. And so that would be our alternative hypothesis. So we have the criteria that we have to meet. And the first one is that the random sample, or it's a randomized experiment. So we can look at our problem here, and it says random sample. So that is satisfied. The second requirement is that the population is normal, or the sample size is greater than or equal to 30. So nothing in this problem indicates the distribution of the population. And we can't reason that this distribution for the population is normal. However, we do have a sample size of 50, and therefore that criteria has been met. The third requirement is that my sample size is less than 5% of my population size. So my sample size in this case was 50. And then you go through and you solve the inequality for big N, and big N therefore has to be greater than or equal to 1,000. So what we're saying is the population size has to be greater than or equal to 1,000. So you have to think about what the population is, and then if that population size would be over 1,000. So my sample is of 50 adult males aged 20 to 74. So then, who take the supplement? So then my population would be all adult males aged 20 to 74 who take the supplement. Okay, they wouldn't make a supplement that would be administered to fewer than 1,000 individuals. So that criteria has been met. We want to go through and therefore determine our level of significance, our alpha, and that's given to us in the problem as 0.05. So now I want to go through and we want to compute the test statistic and p-value to compare alpha, our level of significance, to our p-value. So we go to GeoGebra, and we first check our correct test. We're doing a t-test of a mean. So our null hypothesis was that the mean weight loss was 0. And then our alternative hypothesis was that the mean was greater than 0. So we have to recreate that here and have it as a greater than. Down here, these are my sample information. So my sample mean in the problem was 0.9 pounds, and my sample standard deviation was 1.2 pounds. So we have 0.9, 1.2, and my sample size, this N means my sample size, which was 50. And immediately down here, we have our results. I have it set to 10 decimal spots. If you wanted to, you can change that. If you have it set to like 4 decimal spots, this p-value would be 0. I changed it just to 10 decimal spots so I could see the whole a number that was not 0. So let's go through and write this out. So my test statistic is t, and as you can see down here, my test statistic was 5.303. And my p-value was, this is the one that I had down here at my p, which is when I had the large decimals. I'm going to go through and get to round to the nearest 1, 2, 3, 4, 5, 6, 7 decimal. Okay, so it's going to be 0.00000014. Okay, so I have 0.000014. Okay, so we have to determine what we're going to do. We compare our p-value to our alpha. Our p-value was 0.00000014. My alpha was 0.05. My alpha is much bigger. So, as it says, we are going to fail to reject if my p-value is greater than alpha, and then I'm going to reject if my p-value is less than alpha. So I'm going to reject H naught. And how I can write that conclusion in context is that there is sufficient evidence to believe my claim. And the claim was, so there's sufficient evidence to conclude that the males who take the supplement will have a mean weight loss of more than 0 pounds. Okay. And again, you're writing the claim here in context, so you're going to write this alternative hypothesis in context. So it says, do you think that the mean weight of 0.9 pounds is worth the expense and commitment of a daily dietary supplement? In other words, does the weight loss have any practical significance? So over here, when you think about it, this mean weight loss over 8 weeks was nearly a pound. It wasn't quite a pound. And so you're like, okay, would it be worth it to take this dietary supplement every single day and buy it if over 8 weeks you only lose nearly a pound? Okay, it's going to actually make you lose that pound more than it'll be more likely because it's statistically significant. We have sufficient evidence to conclude that it will do that. However, is this practically significant? Or is it going to be something that you would want to do? So, since we're having not even 1 pound, in 8 weeks, there's statistical significance, but not practical significance.